So coral reefs today are well developed, they are beautiful, but in the process of losing the big corals, which actually work as a barrier. And flattening is a big problem. So underground water, all this yellow is salinity more than 1 gram per liter. So it's beyond being utilized, cannot be used for human, for animals, for anything. So it's a problem which will grow with sea level rise. You know the problem. I mean, the sea level rise, the fresh water is less, especially in the keys where there is just a little amount of water, maybe a few centimeters. They can go very easily. They can become contaminated, or if you explode it a little bit higher than what is required, you lose everything, because as soon as all of this is salt, it's hard to recover. And inland, you saw that there are very strong penetration of the salt water. So we need fresh water, and this will be a problem for the future generations. Not the future, but those which are to come, which are already being in the country. And I don't know. We are taking measures, I mean, reducing the pumping, changing the wells into more inland, but how long can you do that? I mean, for how long you can go inland? We are an island. We cannot go much inland because we go to the other shore. So, in order to understand the problem of sea level rise, we tried to figure out how was the land behaving, because neotectonic movement can either reinforce the sea level, so the inundation, or slow it down. The speed of the what happened? I went away. No, it's there, but it's not here. I lost it. Help. Well, here we are at the beginning. Well, okay. Don't worry. We get there. Just to refresh. You don't forget this. Remember this? Okay. Beach. Be careful. So we are getting there. Don't worry. No, it's good to have a refreshment of what we are talking about. Let's go slowly, no? I don't want to go too far. So, the rates are similar to or larger than sea level movement. So if you have a 2 millimeter a year of sea level rise, and I have 2 millimeter a year of rock or terrain rise, it will be equal 0. But if I have 6, 7, -6, -7, and 2, then it will have more inundation. So that's why we try to learn this. But we are having problems. We are not yet done with this. Because it's difficult, because this has been done during years by the repeat geodetic measurement. It's not satellite, it's not GPS, it's equipment. So you don't have a zero. You don't know where zero is. So we use as zero a mariograph which is nearly zero. It doesn't. There is no sea level rise or sea level down in this one, Casilda. So from there we recover these speeds. And then we have the mareographic data. The importance of the mareographer is that the record gives you a summatory plus minus of sea level plus land movements, because the mareograph is like a stick in the soil, so it moves with the rocks, and the sea level move. So you cannot separate the movement of the rocks or the landscape from the movement of the water. So this is what is actually happening. Actually happening. And you see in blue color is green color and white color is sea level rising. But this blue is 2.4. It's here. It's the longest record. And then green is between 2 and 1 and so on. So it's less. And this is almost a little bit of 0.2 millimeter a year, very little. And this is mostly stable. You know, this is the place which we use for this calculation as 0 here. And sinking, the red color. We are now placing more mareograph, but they will have not a good record. The longest here is 40 years, you see? So, as I say at some point, if you don't have a long set of data in time, you are never clear what is really happening. This is just like a photograph of a problem, and we are working with a photograph. We are not working with a long set like Japan or England or so on. So, but now you have a pattern. From all of them, they are the sea level is usually rising, as you see. Most of them are rising at different speed. And then another issue is that at some point the sea level is higher for a few months and lower through other months. This is a seasonal change in sea level, and you have to take into account this. If you use a middle value to say, let's have the house here, then when comes the peak, your house is below sea level. So you have to work not with middle values, but using the high point. Because for 4 months, your house will be surrounded by water. But this is not all. The situation is worse. Can you see these peaks? Or this one, in the low or the upper part? This means that for some time, you will be with 29 centimeters of high sea level in your house. And this is not a middle value. This is during 3-4 X months during La Niña or El Niño. They affect the Caribbean. So you have to take these values. Otherwise, your house will be, again, below water for 3-4 months, sufficiently to lose everything you have. So these are elements that usually are not taken care of. We have developed this in many discussions and debates, and I found that this is a very important outcome. Look at this is the oldest data we have, and these are big peaks. Big one, you see? And these are mostly related with big changes, not local. Because hurricanes are eliminated mathematically, and every other variation, daily or so, are eliminated. This is just a year one, a big real which really lasted. So this is the situation. So sea level record, again, is not long, but is showing up something which you combine with the observation that the seashore is retreating, we have erosion in the beach, and here you just, after a little bit of rain or sea wave, you can have this rod full of water. This was not meant to be like that. I mean, when they built this, the engineers were not considered to have a swimming pool in the middle of the rod. So, this is Varadero Beach. There are big, important resorts. We were there. We went to a place called Al Restaurant. He had a restaurant there. We discovered that our dear Professor Al Hein had a restaurant there. So, look. So something is going on. Something is going on. And look at here what happened. Erosion again. So we are losing the seashore are in a process of transformation. And as I told you during Enos, 37 centimeters for a few months. That's a bad record for everything. So at the end, we found that all these blue color areas are in high risk. There are towns there, fish towns, people who live from fishery. There are some important factories there which have to be removed, because when you go to plan the future, you first have to look at the hot spot, because you can probably move a small town inland or some other place, 5,000 people, 10,000 people or less. When you have a big factory, which is a very expensive construction, but also provide work for many people, I mean, that's something different. And you have to take care of it or you lose it. And that's what is going on now. And in the other places, as I told you, it's not so bad. I mean, in the yellow coastline, but we are still looking forward for more data. We keep working. Then I would just show you quickly what are we doing. We are working sometime at the detail of 10,000 scale for local places which are clearly in higher risk. Here, for example, this is Santi Spiritus, what may be the inundation area for 2100 year. Here is Havana, the flooding, how far will reach. You see some of this area is to be flooded, especially by extreme waves, something that happened in the past, as I told you, once in a while, and now comes to be more common. Eastern Cuba is a mountain area, but then the lower, the flat area is going to be flooded by extreme waves again. These are all, you see, I told you about the rivers who became flooded by quaternary sea level rise. These are all antique valleys. And then they are going to be also flooded now inside by the rain during high storm. So all this is calculated. Here inside Havana, how rain will provide flooding in some neighborhoods. So we have all this information. And the best we can do is to teach the people how to react in front of this. So I have this series which is named Protect Your Family From. These are booklets, there are 8 of them, and have been reproduced many times for community and others. You see, it's a very simple one with a lot of photographs and drawings, and try to show you. The idea is, what is the danger and the risk, and then how to be prepared in advance. And just a little bit what to do in the moment that things are happening. Because in the moment you have to run. I mean, there's not much to do. But if you are thinking of building a house or building a highway or doing some major investment, you have to think for the future, not in the present time. And we have done this, and now we have this also for kids. Will be a book next year, which will be part of the education, the common education for kids. Something I was able to participate only also in El Salvador. They introduced these booklets adapted to El Salvador, and now is part of the education of that the kids receive. So these are part of those booklets. And then also we have posters. This is for school mode. Also we prepare many documentary films about climate change, about some geohazard, about earthquake. If you go to YouTube, and search Iturralde Vinent 2011. My God, what a year. And then you will find many of my documentary films there about this. I work with a TV producer. I mean, it's a professional TV producer. Here you can see the side where the documentary film are described briefly, just not the last one of this year. So also on the TV there have been lectures on environment, hydrometeorology, climate change, geography, geology, seismology, and everything else. Going through many months, one lecture every day in a low level so everybody can understand. So in conclusion, we know that coastal marine areas are under different level of stress and transformation are taking place. So we need to adjust and first change the way of thinking. Usually we think, this cannot happen to me. Then come enlightening, and don't enlighten you, just kill you. So be careful with enlightenments. Thank you very much.
Gosh, so much big questions. I mean, we're struggling with the same thing here in Florida. So here's another country dealing with an issue not too far away. Well, I'll ask you a question. Maybe get things started, I hope. I was impressed with downtown Havana and how the Malecon, which is one of the most famous passage roads in the world, is like the Champs-Elysees in France, Malecon.
Yeah.
And yet it's being slammed by waves, and all that salt water is going into those buildings, and so those buildings are being heavily corroded as a result of all the salt spray. And it's just going to get worse. And Havana is one of the famous cities of the world, and yet it's decaying as a result, partially as a result of this process. So what can the government do to prevent that from happening? You can't move it. You can't move it.
Yeah, you can move. You can. Let me tell you, it's interesting that recently I came to see an information that in 1906 there was the same event that I show you here. Same, very tall wave. They describe the wave going on top of the Morro Lighthouse, like now, again in 1908. And they decide to build the Malecon as a result of this, to fix that problem. And it maybe worked until 1964 or 65 when start again. So something is going on. The sea level is rising there. For example, in one neighborhood west of Havana, they open a channel to drain the waters of the hurricanes and so on. Now the sea is draining into they have to close the channel. So what do you do? I mean, I have no idea. We repair and repair, and we remove, at some point they were building cafeterias and stuff in the seashore. Now it's not anymore. The real values are removed from these places. It's the best you can do. And I have been seeing some houses built in the 30s, and they were high. So they knew that something was wrong, and they tried to fix it. But modern houses are built down to the bottom. So every time that sea level, there is an extreme wave event like this, the engines for water of the house is broke or damaged. The source of fresh water is damaged. This will take a lot of time and a lot of money. I know that something is going on slowly. People don't want to move into these areas right now. At some point it was fancy to live near the Malecon. Now it's fancy to live far away from the Malecon. If you have a house there, it's very difficult that you will find somebody who will move there. So it's a natural process at some point that will modify this. And what is doing the government is trying to understand with our data what to do, and they will have to be rebuilding something or removing from the first level everything that is value, because otherwise it's going to be.
Looking at your neotectonic map of Cuba, so if I understand correctly, the southern part is.
I don't have a neotectonic map.
When you talk about neotectonics?
I didn't map. Why? Because the problem of we don't have a real zero. So I cannot tell.
Well, then how can you assert that at the southern part you have more?
No, this is by geomorphology. You see a set of marine terraces. In one place you have 15, in other you have 4, in other you have 2, and in others you have the wetland, just the wetland. Generally, landscape or relief is related with tectonic movements. So in general, these mountains and this shore with many marine terraces should have been moving up at some point. But now they are moving down because we are the sea level rising. No? And we have several marine terraces submerged. So the sea level is rising, definitely. But there is less, it's a little problem if you compare with the low land where there is a swamp, it's already inundated. So 5 centimeters will be 5 centimeters all the way to the end of the wetland. That's the idea. We are not yet introducing the data from geodesic